Dave the pharmacist here again. So let's talk about the use of LDL in the body. In fact, we talk about LDL as being bad cholesterol, but in fact, LDL has a use in the body, and probably 100,000 years ago, I always refer to sort of cavemen and ancient humans when we talk about heart disease, because I think it explains a lot of the issues that we encounter in today's world. So if you think about LDL about 100,000 years ago, and somebody in a hunter-gatherer who doesn't eat that much, and when they do eat, they don't eat a lot of fat, they don't eat a lot of cholesterol because they're eating largely a plant-based diet. And so when they do get fat and when they do get cholesterol, these are very valuable resources for the body, and they want to make sure that the cells of your body have access to them, because it turns out that cholesterol, the actual cholesterol now, not the LDL, but the actual molecule of cholesterol is something that we all need to survive. All of us, every human needs cholesterol to survive, because cholesterol seems to be a really useful molecule. And we use cholesterol as a basic building block for many of parts of our body. For example, our bodies are made up of cells, brain cells, heart muscle cells, kidney cells, skin cells, all connected together in an amazing way. And so all of the cell membranes, of course, the way that a cell has to work is it has to have a nice cell membrane or a skin on the outside of it to make sure that it doesn't, it can separate the middle important part of that cell from the outside world. So as it turns out, cholesterol is a basic building block or a brick that is used to make cell walls. Cholesterol is also used to make hormones and lots of things. So it turns out cholesterol must be a really, really useful molecule. It is a really useful molecule for the body. And so cholesterol is not necessarily bad. It's good as long as you have a good balance of cholesterol, your demand versus your supply. So let's take an example about how cholesterol and LDL cholesterol is used in the blood. And I'm going to use let's just use a simple example of a cell. Let's say just right on your skin, a skin cell. It's the easiest way to show how cholesterol and LDL cholesterol actually can be good. First thing before we start is one unique thing about cells in our body is that the majority of cells in our body actually have machinery that can build or create their own cholesterol. So if you've got a basic molecules, if you've got a supply of the basics molecule in a cell, that cell can stick that into an assembly line or a factory inside the cell and make its own cholesterol if it needs it. So let's look at what we mean by that. So here's a skin cell. One skin cell out of probably, I don't know how many billions of skin cells that cover our body. Here's one skin cell. And this skin cell has a membrane on the outside that will be made, that will need cholesterol will be a big part of the sort of building blocks of this cell membrane. And inside, here's the cell's nucleus where they keep their DNA, the copy of all of the information, the map of your entire person is kept within the DNA. So, one of the things that is important for a skin cell here is that this skin cell, let's say that you have an accident, or let's say a caveman has an accident, and he has big scrapes in his skin, and so he has a wound on his skin that needs to be covered over very quickly, otherwise it's going to get infected. So so imagine you've got a caveman just had a fight with a tiger. Tiger scratched up his arm, and now he's got these big gaping wounds in caveman's arm. Now back in caveman days, there are no hospitals. There are no way to to fix that up. There were probably some natural ways and some mud they'd stick on it. I don't know. But again, really, it's really important that this caveman, it's important that his skin divides very rapidly to try to cover over the exposed part of that arm. Otherwise, it will get infected and he could die, or whatever. So for caveman, it was really important that those skin cells divide and cover over that as much as possible. So this skin cell, if it's anywhere near the area where that injury is, this skin cell is going to have to divide. It's going to have to divide into two. And so, of course, the way it would do that is once it's stimulated to divide, basically what we'll do is it will start to make more cell wall. It'll make enough cell wall for two cells. So that's kind of how it will look, and then it'll copy up its DNA. It's sort of the guts of the cell. It'll copy up that DNA to make two cells, and then of course eventually when everything is ready to go, then that one cell will just have divided into two. So that makes sense. This is probably happens all the time. And skin cells need to divide just like all sorts of other cells need to divide into two. Now, if this is a very big wound, now this cell is going to have to divide, that cell is going to have to divide, and then hopefully by tomorrow morning or in a little while, enough skin cells will be made so that that injury can be covered over and essentially save this poor caveman's life after fighting a tiger. Brave guy. So, think about this process and think about how much cholesterol is going to be needed, because this guy's got to make all this cell wall, and then this guy's got to make more cell wall. So even if this guy has enough, if he has enough resources inside his cell to make his own cholesterol, so as I said, that there is machinery inside these cells to make their own cholesterol. But of course, you need to have the resources. You need to have the basic ingredients to do that. And then if this caveman hasn't eaten in a long time, maybe this cell doesn't have a lot of resources to be able to make enough cholesterol to do this. So anytime a cell in the body doesn't have enough resources to make the cholesterol it needs, what it does is it will build on the outside of that cell, it will build a receptor. Now, I hope that you, if you looked at our section on beta blockers, our blood pressure / heart medications, you should already be familiar with this concept of a receptor. We talked about a receptor for adrenaline when we talked about beta blocker medications. But in this case, this is not a beta receptor. This is an LDL receptor. Now, I wonder, hopefully you're starting to think about already what this LDL receptor would be. So here's a skin cell. Oh, sorry, I forgot to draw the guts of it here. Here's a skin cell that has the machinery to make cholesterol, but that machinery is not able to work right now because it doesn't have the resources inside the cell are not enough. So this cell needs cholesterol to replicate or to make more of a cell wall. So it will make an LDL receptor on the outside of that cell wall. And I won't talk too much about receptors because we talked about them with adrenaline, but hopefully you'll remember and you'll be able to kind of see that this LDL receptor, of course, what do you think that's made for? Well, it's made for an LDL particle. And so LDL particles that are floating around in the blood can come. If there's an LDL receptor out, it can park on this LDL receptor. This LDL particle can park there. And once this has grabbed an LDL receptor, so this LDL receptor, once it has LDL on board, it will essentially eat or engulf this LDL. So now this LDL is inside the cell, and then the cell will attack it and break it down so that the cholesterol is released. And now this cell has cholesterol that it has taken from the blood. This LDL has basically acted as a donor of cholesterol to a cell that needs it. Now this cell can go on and do its dividing and make its cell walls as it moves. So I hope I'm changing